This video is for mile marker 3, practice 1, question 1. If you look at question 1, the first thing we want to do is try to figure out what tool are we going to use to solve this problem. So in question 1, we notice that we're given a side and an angle. We're looking for a side, and hopefully it stands out to us that that is a 45-degree angle. So question 1 is a question where we can use what we know about right triangles. Special right triangles. So if we're given a side and an angle, and that angle is 30, 60, or 45, we can use our special right triangle patterns here. So let's review our 45, 45, 90 triangle. So on the mile marker, when you get to question 1, if I were you, I would write either like SRT for special right triangle, or you might even write 45, 45, 90. Okay, and when we look at any 45, 45, 90 triangle, we know that the two legs have to be the same length. So we know it's an isosceles right triangle. I'm going to use the letter L right now to just represent the length of each leg. And then the other thing we know about these 45, 45, 90 triangles is their hypotenuse is always the length of the leg times the square root of 2. So I could call the hypotenuse L root 2. So then if we look at the problem in number 1, we're given one of the legs, so it's really easy to find the hypotenuse. So if the leg is 19, x, the hypotenuse, has to be 19 root 2. So that's the answer to number 1. I'm not going to go through the trig method for this problem, but if you either plug 19 root 2 into your calculator or you use the trig method, the other answer you could get here is the decimal approximation, and that's going to be 26 and 870 thousandths. You've got to round this precisely to 3 decimal places, but I would accept either the simplified radical or the decimal.